Good day, ladies and gentlemen. Last week we discussed the application of calculus in economics, and we talked about how we can use calculus to investigate a specific production function like the Cont'd function. We also talked about the various optimizing behavior of a firm and how we can use the bordered Hessian and the Hessian determinant we earlier discussed to solve problems of a neoclassical firm. Now, today we are going to also have an application of differential calculus to the consumer. So here we're talking about consumer utility maximization, and once consumer has maximized utility, there are certain issues that arise, and that is the partial elasticities. That is the responsiveness of these demand to certain parameters in the demand equation. I am Daniel Kabunatri and your tutor for this course. So this is a session that we have, and what I intend discussing with the consumer utility maximization, partial elasticities, and here I'll look at three things: own elasticity, cross elasticity, income elasticity, and then there are implications in economics. Now, every individual tends to derive satisfaction from whatever he or she consumes, right? And this satisfaction or utility is derived from whatever we do. Now, assuming we consume only two sort of goods, okay, Q1, Q2, there is a utility that we obtain from consuming these two goods, okay? We will assume that these goods are positive, okay? They are quantities that the individual consumes, and they are all sort of positive. There should be some mathematical formula that links, this Q1, Q2 that determines the utility or satisfaction of this, individual. Now, it's quite important to know that this utility function is continuous and also ordinal in nature. The ordinal in nature is that it increases, but by how much it increases, we don't know. We are able to make a choice that if we have a consumption set here and a consumption set here, we are able to know that this one gives us more satisfaction than the other consumption set. But by how much satisfaction it gives, we are not able to know that, and that explains the ordinal nature of our utility function. Now, as human beings, we are all constrained, right? We are all constrained by the amount of income that we have. And in my analysis here, I assume that we are consuming only two goods, Q1, Q2, and the prices are P1 and P2. So we have a budget constraint of this nature. So if we are consuming all these only these two commodities, then the question we are solving is that we are trying to maximize our utility subject to our budget constraints, okay? Which mathematically we can write it in this form. And notice that this is something we've met, right? We've met the solution to this equation or this problem, and it's constraint optimization, which we discussed in the case of the firm. So we look at how that applies to the consumer. Now, to do this, as you know, we form our Lagrangian, okay? This is an objective function, this is our constraint function, and then we take the first order derivative. We have this equation, and what happens is that we can more or less manipulate the first equations, right? From these equations, we can have this relationship. We can also have this relationship that tells us that our lambda is always a constant. All right, so it means that the marginal utility divided by the price must be the same for all the commodities and must be equal to the lambda. This sort of equations we obtain from the first two over here, right? And that is the implications that we have. Now, we know that in this situation, lambda is what? The marginal utility of income, which means that if income increases by a small margin, utility will increase by that small margin. We can also have this relationship. What we have over here is the marginal utility with respect to the first commodity. So the ratio of what it means that the ratio of the marginal utilities is equal to what? The price ratios. And these conditions, we also use them very well to be able to do analysis in utility function. Now, once we have these functions, right? Once we have these functions, notice that we can always solve it. We have these equations. We can always solve for Q1 and Q2, right? Q1 and Q2. And Q1 and Q2 will be in terms of P1, P2, and then the income. So if we assume that this is the solution, so Q1 will depend on P1, P2, and income. Q2 will also depend on P1, P2, and income. Also, lambda will also be in terms of the same variable. And this gives us what? The demand. Okay? This is the demand that will maximize our utility if we have the problem at hand to solve. Notice that once it is a constraint optimization, we have to form our bordered Hessian determinant. And once we are dealing with two variables, even we have a 3 by 3 matrix, but then we have 2 here and our bar here to signify that we are dealing with a bordered Hessian determinant. And when we evaluate the determinants, as you see over here, we have this equation, and it's going to be greater than 0 since we are dealing with a maximum. Further, we can plot these demand into the equations, and then we have our maximum satisfaction based on our maximum demand. Again, we have looked at a situation where we have 2 commodities, okay, but we can have a number of commodities, Q number of commodities. In that case, we have this sort of objective function, utility function, which we are maximizing subject to this constraint, maximizing in terms of P1, Pn, and then lambda, and we can comfortably find our first order differential and solve for our, maximum value. Let's look at a specific example. In this example, there's our utility function, a nice function. There's our constraint, and we are supposed to find the quantity demanded. Okay, we are supposed to construct the demand function for that consumer, and then we have been given specific values, right? And the value here is X, I think, right? This one should be Y, and the income is 68 here. We need to know which one is P1 and P2 here, and which one P1 is I, right? I think there's a small, over here. One of these should be P1, the other one should be P2, and there's the income. So if we look at we form our Lagrangian, the first order, we manipulate this equation, and then what do we get? We get this one to be our demand, okay? Expressed in terms of P1, P2, and I. In the case of Y, our demand expressed in terms of, P1, P2, and I. So what happens is that our Lagrangian 2 is here, and then what happens is that we have been given our P, right, X here to be 2, and then we have our income, and then we have our P, Y here to be 4. So this is the value that we're given over there. So a matter of slotting these values into the Lagrangian here, and we get this. We also have to slot them over here, right, X and Y, and when we slot them, we the solution has been provided over here. But then all we have to do is that we slot these values into these equations that we have here, X1 and X2, and then we get the actual quantity demanded. So in a nutshell, we can use calculus to also, maximize the, utility of a consumer who is constrained by his budget. Right. There's an activity here which I would like you to try your hands on, and let's meet at the chat room if you have any problem. Now, once we have these, I would like us to now discuss, what we call partial elasticities. You may have discussed elasticities, right? But here the emphasis is on partial elasticities. When we maximize our utility function, notice that we got a demand Q1 depending on P1, P2, and I, and also demand for the second good depending on P1, P2, and I. Okay? Now, when we have these ones, we can have three different elasticities. We have own elasticity, cross elasticity, and then income elasticities. Okay? And each and every one of these elasticities points to or have got some implications for the relation between, those commodities at hand. Now, let's take each of them and try to understand. The own elasticity of demand, which I'll denote by D11 here, of this input Q1 is defined as the proportionate rate of change in demand Q1 divided by the proportionate rate of change of its own price. Okay, so here this is E11 giving us what we have over here. This is P1, this is Q1, this is the marginal sort of the Q1 respect to what? 1. So when we evaluate this one, when it's numerically high, then it implies that the quantity demanded responds proportionately well to change in price. Okay, so the value here will determine how the quantity demand of that commodity responds to its own, price. And in many situations, if you have your own elasticity being equals to 1, then we have demand to be what? Unitary elastic. If it's less than 1, then it means we have inelastic. And then when it's greater than 1, it means we have, elastic sort of what? Demand. And in the case when it's elastic, we talk about the goods being luxury because the consumer experience with a decrease, consumer expenditure will decrease with increase in price. And in this case, we look at it as a necessity because the consumer's expenditure will increase with increase in price. So, own elasticity of demand permits us to see whether a commodity is a necessity or a commodity is a luxury. Let's look at cross elasticity. Here, we're talking about a proportionate change in price, of one commodity and its impact or relative to a proportionate change in output of the other commodity. So here you see that this is the Q1, the Q2, and this is P2 or Q1. So you're knowing how, quantity demand of Q1 changes when the price of the other commodity, changes. Now, cross elasticity of demand permits us to know whether two goods are complementary or substitutes, right? For substitute goods such as butter and margarine, there's the classical example. The cross elasticity will be what? Positive. On the other way around, when it is a negative, then we're talking about what? Complementary sort of goods. When the cross elasticity is negative, then we're talking about the two goods being complementary. Now, when you look at these two goods, when you have the cross elasticity being greater than 0, then you have substitutes here, and then we have complements here, and then when it's equal to 0, then it suggests that there is no sort of a relation between the two commodities. Now, the last thing, it's about income elasticity of demand. So here, we would like to see how demand of the commodity responds to a change in income of the commodity. And the similar formula applies. And if we have the income elasticity to be equal to be greater than 0, then we talk about, a normal good. And then when it's less than 0, we have inferior goods. So income elasticity permits us to know whether a good is it's a normal good or a good it's an inferior good. I have some examples here. So we have a certain demand function. Our objective is to investigate, right, the relation that good have with respect to the prices P1, P2, P3. And we are supposed to calculate the cross elasticities and interpret the relationship between the goods. So if you look at the first one over here, you can take your time and go through the solutions here, right? The solutions here, the derivatives are being made, the cross elasticities are being calculated in these situations, and the price are being put in, and then you evaluate it, and you are able to more or less discuss the two goods. There is also an activity here, and I would like you to take your time and go through these activities here. You are supposed to find the price elasticity of demand, the cross elasticity, and the income elasticity of demand, as we have already discussed. And I think if you have any problems, we can meet at the chat room. Another example here where a specific level 300 students has got a demand function depending on the prices and the income. Demand function, as we know, at our level depends always on price and income, and these are the questions that we are supposed to discuss. Thank you very much.